Imagine a world where you could fill your car with water and drive for thousands of miles. Picture yourself pulling up to a futuristic filling station, not to pump gasoline, but to fill your tank with nothing but water. No more petrol stations, no more exhaust fumes. The air would be cleaner, the skies clearer, and the world a much greener place. Just pure, clean energy from a readily available source. Water is everywhere, and harnessing its power seems like a dream come true. It's a compelling idea, isn't it? The thought of driving a car that runs on water captures the imagination and inspires hope for a sustainable future. The idea of a water-powered car has been around for decades. Inventors and engineers have long been fascinated by the potential of using water as a fuel source. It's been the subject of countless inventions, patents, and even a few conspiracy theories. Some believe that the technology has been suppressed by powerful interests. But is it really possible? Can we truly harness the power of water to fuel our vehicles? Can we really power our vehicles with nothing more than a bit of H2O? The science behind it is both fascinating and complex. The short answer is, not quite. While the idea is tantalizing, the reality is that water itself isn't a fuel. While the concept of a water-fueled car is appealing, the reality is a bit more complicated. Water can be used to produce hydrogen, which can then be used as a fuel. You see, water itself isn't a fuel. It's a compound made up of hydrogen and oxygen. It's what we get when we burn a fuel like hydrogen. By splitting water into its component parts, we can produce hydrogen gas. This hydrogen can then be used in fuel cells to generate electricity, which can power a car. So while we can't directly power a car with water, we can use it as a source to produce a fuel hydrogen. Hydrogen fuel cells are a promising technology, but they come with their own set of challenges. Let's dive into the world of hydrogen and see why it's both promising and problematic as a fuel source. Hydrogen is the most abundant element in the universe, and it has the potential to revolutionize the way we think about energy. However, producing hydrogen in a sustainable and efficient way is a significant challenge. Most hydrogen today is produced from natural gas, which is not a renewable resource. Researchers are exploring ways to produce hydrogen using renewable energy sources like solar and wind power. This would make hydrogen a truly green fuel. Hydrogen fuel cell cars are already on the road and they offer some exciting advantages. They produce zero emissions and their only byproduct is water vapor. Imagine driving a car that emits nothing but water vapor. It's a vision of the future that many are working hard to make a reality. But there are still hurdles to overcome. Hydrogen storage and distribution are complex and costly. Building the infrastructure for hydrogen refueling stations is a massive undertaking. Despite these challenges, the potential of hydrogen as a clean, renewable fuel is undeniable. The dream of water-powered cars may not be as far-fetched as it once seemed. As technology advances and our understanding of hydrogen grows, we may one day see a world where water truly powers our cars. Until then, the journey continues, fueled by innovation and the quest for a sustainable future. Hydrogen is a fascinating element. It's the most abundant element in the universe, and it packs a serious energy punch. When hydrogen burns, it releases a lot of energy, about 3 times more than gasoline by weight. That's why it's used as rocket fuel. But here's the catch. Hydrogen doesn't exist naturally in its pure form here on Earth. We have to extract it from other sources, like water, which is where things get a bit tricky. To get hydrogen from water, we need to split the water molecules apart. This process is called electrolysis, and it involves using electricity to break the chemical bonds between hydrogen and oxygen atoms in water. Sounds simple, right? Well, not so fast. Electrolysis requires a fair bit of energy itself, and to make matters worse, the hydrogen produced through electrolysis needs to be compressed and stored, which also takes energy. So, hydrogen has a lot of energy, but it's also a bit of a diva to handle. It's like that high-maintenance friend who has a lot to offer but requires a lot of attention and care. Let's compare it to our old friend, gasoline, to see how they stack up. Gasoline has been around for over a century, powering our cars, trucks, and even planes. It's familiar, reliable, and we have a vast infrastructure built around it. Hydrogen wins this round on a per-kilogram basis. It packs a punch with its high energy content, making it a powerful contender in the energy game. However, gasoline is much denser than hydrogen gas. This density means that gasoline can store a lot of energy in a relatively small space, which is a significant advantage. This means you can store more energy in the same volume of gasoline than you can with hydrogen gas. Imagine trying to fit the same amount of energy from hydrogen into your car's fuel tank. It would require a much larger tank or higher pressure. Gasoline is easy to store and transport in a liquid form. It's stable at normal temperatures and pressures, making it convenient for everyday use. Hydrogen gas, on the other hand, is very light and takes up a lot of space. Its low density means that to store a usable amount, it needs to be compressed or liquefied, which adds layers of complexity. To store a usable amount, it needs to be compressed under high pressure, which adds complexity and cost. This high-pressure storage requires specialized equipment and safety measures, making it more challenging to handle. We have a massive infrastructure in place for gasoline, with petrol stations on practically every corner. This extensive network makes refueling quick and convenient for millions of drivers every day. For hydrogen, the infrastructure is still in its infancy. There are only a limited number of hydrogen refueling stations, mostly concentrated in specific regions. Building this infrastructure will take time, investment, and a coordinated effort from various stakeholders. Despite these challenges, hydrogen holds great promise for the future. Governments and companies around the world are investing in hydrogen technology, recognizing its potential to reduce carbon emissions and provide a sustainable energy source. Hydrogen can be produced from renewable sources like wind and solar, making it a clean and green alternative to fossil fuels. Hydrogen-powered vehicles from buses to trucks are already on the roads, showcasing the potential of this versatile fuel. Imagine a future where hydrogen is as common as gasoline, with refueling stations in every city and hydrogen-powered vehicles driving us towards a cleaner, greener world. It's a vision that many are working hard to make a reality. So, while hydrogen may be a bit of a diva now, with the right investments and innovations, it could become the star of our sustainable energy future. The tale of these two fuels is still being written, and the next chapters promise to be exciting. Section 5. The challenge of storing hydrogen. Storing hydrogen is one of the biggest hurdles to its widespread adoption as a fuel. Remember, hydrogen gas likes to spread out a lot. To store enough hydrogen to power a car for a reasonable distance, you need to cram it into a tank under very high pressure. These tanks are bulky, expensive to produce, and require special safety measures. Imagine driving around with a giant balloon of flammable gas in your boot. Not exactly reassuring, is it? Section 6. The 1,000-kilometer claim, separating fact from fiction. Now let's address the elephant in the room, the claim that a car can run 1,000 kilometers on a single liter of water. Sadly, this is where reality hits the brakes and the claim skids off the road into a ditch of impossibility. 1 liter of water, even if perfectly converted into hydrogen, simply doesn't contain enough energy to propel a car that far. You'd need a tank the size of a small swimming pool to store enough hydrogen gas to achieve that kind of range. Section 7. Hydrogen fuel cells, a different approach. So far we've been talking about burning hydrogen in a combustion engine, much like we do with gasoline. But there's another way to use hydrogen as a fuel cells. Fuel cells are electrochemical devices that convert the chemical energy of hydrogen directly into electricity, without any combustion. They produce electricity, heat, and water as byproducts, no nasty exhaust fumes. Section 8. Hydrogen cars today, the Toyota Mirai. Fuel cell technology is already being used in a handful of cars on the market today, like the Toyota Mirai. These cars are essentially electric vehicles that use a hydrogen fuel cell instead of a battery to power their electric motors. They offer some advantages over battery electric cars, such as faster refueling times and longer ranges. However, they also face challenges like the high cost of fuel cells and the lack of a widespread hydrogen refueling infrastructure. Section 9. The future of hydrogen cars. A bumpy road ahead? So, will we all be driving water-powered cars in the future? Well, it's complicated. The concept of hydrogen cars has been around for decades, and while it sounds like a perfect solution to our fossil fuel dependency, the reality is far more nuanced. While the idea of using water as a fuel source is appealing, the reality is that hydrogen, even when extracted from water, faces significant challenges as a mainstream automotive fuel. Hydrogen is the most abundant element in the universe, but harnessing it efficiently and safely for everyday use is a monumental task. The storage issue, the lack of infrastructure, and the high costs associated with hydrogen production and fuel cells are all significant hurdles that need to be overcome. Hydrogen is highly flammable and requires robust storage solutions, which are currently expensive and not widely available. The high costs associated with hydrogen production and fuel cells are all significant hurdles that need to be overcome. Producing hydrogen in a clean and efficient manner is still a challenge. Most hydrogen today is produced from natural gas, which is not a sustainable solution. Scientists are working on more eco-friendly methods, but these are still in the experimental stages. That's not to say that hydrogen doesn't have a role to play in the future of transportation. It has the potential to revolutionize certain sectors. It might find its niche in heavy-duty vehicles like trucks and buses, where the benefits of fast refueling and long-range capabilities are more critical. These vehicles often have set routes and centralized refueling stations, making the infrastructure challenges less daunting, or in niche applications where fast refueling is critical. For example, in industries where downtime is costly, hydrogen's quick refueling time could be a game changer, but as for your average family car, the situation is different. The convenience and established infrastructure of petrol and electric vehicles make them more practical for everyday use. Well, it looks like petrol and batteries are here to stay for a while longer. Electric vehicles in particular have seen significant advancements in battery technology, charging infrastructure, and overall efficiency. While hydrogen cars hold promise, the road to widespread adoption is still fraught with challenges. For now, it seems that the future of personal transportation will continue to be dominated by petrol and electric vehicles, with hydrogen playing a supporting role in specific sectors.